Okay, now let's take a look into hypothesis testing for variance and ratio of variance. Okay, so we go to hypothesis testing for variance first. Okay, so the five steps that involve in conducting hypothesis testing for variance is first, as usual, you need to clarify the hash naught and h1. So our hash naught is sigma square equals to sigma square naught. Okay, sigma square naught is equivalent to any value lah. Okay, and then h1, it can be left tail, right tail, or two tail. Okay, and then the second step is the test statistic. So the test statistic that we're going to use here is called chi-square. So chi-square equivalent to n minus 1 s square over sigma square naught. Okay, and then step number 3, identify the critical value. So for the left tail, the critical value is chi-square 1 minus alpha and the degree of freedom n minus 1. And then for the right tail, the critical value is chi-square alpha and degree of freedom n minus 1. But for the two tail, we have two rejection region or critical value. First, at the left side, we have 1 minus alpha over 2 n minus 1, and at the right side, we have chi-square alpha over 2 n minus 1. Okay, don't forget to divide alpha with 2 for the two tail. Okay, and then step number 4, reject hash naught. Okay, the decision rule, sorry. For the left tail, reject hash naught if chi-square or test statistic less than chi-square 1 minus alpha n minus 1. Okay, for the right tail, reject hash naught if test statistic greater than the critical value. And for the two tail test, reject hash naught if chi-square less than chi-square 1 minus alpha over 2 n minus 1, or chi-square greater than chi-square alpha over 2 n minus 1. Okay, other than that, we also can use the p-value approach. Okay, for this one, if it was given in the output, better for you to use the p-value approach. Okay, and then last step sekali kita buat make a decision and conclusion. Okay, now let's take a look into example 26. The standard deviation of the breaking strength of certain cable produced by a company is given as 110 kilogram. After a change was introduced in the process of manufacture of this cable, the breaking strength of a sample of 8 cables show a standard deviation of 80 kg. Is this enough evidence to indicate that there has been a decrease in variability? Use alpha equals to 0.05. Okay, so the keywords variability is referring to the variance. Okay, so we want to test on the variance. Okay, now what are the information that given to us here? Now kita ada value standard deviation, which is sigma. So we have sigma equals to 110. Okay, sample standard deviation, and then we have n equals to 8 and standard deviation s equals to 80 kg. Okay, now first step kita hash naught and h1. Since we want to test on the variability, which is referring to variance, so variance equals to 110 versus variance less than 110. Sebab apa? Dia kata decrease. Okay, so this one is left tail. Second step, calculate the test statistic. So our test statistic is chi-square equals to n minus 1. 8 minus 1 s square 80 kuasa 2 bahagi dengan sigma square. So it was equivalent to 3.70248. Okay, third step, find the critical value. So since this was a left tail, so chi-square 1 minus alpha 0.95, n minus 1 7 equals to, so refer your chi-square table, we get critical value is 2.167. okay, so chi-square dia punya graph dia lain sikit, dia flat dekat sebelah kanan, dia more flat to di sebelah kanan. okay, so this one is left tail, so at the left side the value of the rejection region is equivalent to 2.167. okay, so the decision rule is reject hash not if test statistic less than 2.167. okay, now look at our test statistic value. We get 3.702548, which is greater than 2.167, which means that the test statistic does not falls in the rejection region. okay, so the conclusion is, since the test statistic is greater than 2.167, fail to reject hash not. So when we fail to reject hash not, this means that sigma will equals to 110. So the conclusion is there is no enough evidence to indicate that there has been a decrease in variability. Maksudnya tak ada, since we fail to reject hash not, so no enough evidence to indicate that the variability was decreased. okay, now let's take a look into the hypothesis testing for the ratio of the two variances. okay, kalau tadi kita nak compare only one not compare, we want to test on the one variance. This one we want to compare if we have two population variance. okay, so the null hypothesis dia adalah sigma 1 square equals to sigma 2 square, or you can write also sigma 1 square minus sigma 2 square equals to 0. hash 1 kita ada left tail, right tail and two tail. okay, for left tail either sigma 1 square less than sigma 2 square, right tail sigma 1 square greater sigma 2 square, for the two tail sigma 1 square does not equal sigma 2 square. okay, and the test statistic here we're going to use F distribution. so the formula is very simple, S1 square over S2 square. okay, and then look at the critical value. okay, for the left tail we have F1 minus alpha, N1 minus 1, N2 minus 1. okay, for the right tail kita ada F alpha, N1 minus 1, N2 minus 1. and for the two tail test we have critical value, ada dua lah, F1 minus alpha over 2, N1 minus 1, N2 minus 1, or F alpha over 2, N1 minus 1, N2 minus 1. okay, saya ingat ya, kalau two tail saja kita perlu bagi alpha dengan 2. okay, decision rule. okay, for the left tail we will reject hash not if test statistic less than the critical value, and for the right tail we will reject hash not if test statistic greater than the critical value, and for the two tail we gonna reject hash not if test statistic less than the critical value, or or test statistic greater than another critical value. also we also can use the p value if you are given the p value. okay, and lastly we make a decision and conclusion. now look example 29. okay, a new chemical process is developed for the manufacture of nickel cadmium batteries. The company believes that this new process will increase the mean lifetime of a battery by 5 hours as compared to that of battery produced by the old process. okay, so we have two population here, old process and new process, and all the information are given in the table. okay, assuming all battery lifetime to be normally distributed, test at 5% significant level whether there is a difference in the variability of the two process. okay, so ingat ya, keyword variability adalah kita nak test on the variance. okay, now kita terus kepada H0 H1 kita lah. Okay, since nak tahu ada different ke tak, so hash note kita boleh buat sigma 1 square equals to sigma 2 square. Our H1 kita sigma 1 square does not equal sigma 2 square. So this one is 2 tail test. Okay, step yang kedua, calculate the test statistic. Very simple. F equals to S1 square over S2 square. So 9.1 kuasa 2 bahagi dengan 8.3 kuasa 2. Sebab apa dia bagi value standard deviation kan, formula adalah S square. Okay, so 9.1 divided by 2, sorry, 9.1 power of 2 divided by 8.3 power of 2, we get 1.20206. Okay, number 3, find the critical value. Okay, since this one is two tail test, so kita ada dua value of critical lah. Yang pertama F, yang pertama adalah F1 minus alpha over 2, N1 plus N1 minus 1, N2 minus 1. So 1 minus 0.025, we get 0.975, and 12 dan 14. Okay, so look from the table, kita kena cari 1 per F 0.025, 14 dan 12. Okay, so the value is 3.2367. Okay, yang ni saya dapat interpolation so sebab dia tak ada exact value dalam table, tak ada, so we need to do interpolation. So saya dapat 3.2367. Okay, 1 over 3.2367, we get 0.30896. Okay, itu dekat left side. For the right side, we have F 0.025, 0.025, 12, 14. So this one value dia ada dalam table, kita dapat 3.05. Okay, so kalau kita lukis kita punya value dia adalah this one. At the left side is 0.30896, at the right side 3.05. Okay, so kita boleh tulislah dia punya decision rule. Okay, reject hash not if test statistic less than 0.30896 or test statistic greater than 3.05. Okay, now look at your F value ataupun test statistic value. Value dia adalah 1.20206, which is does not falls in the rejection region. So we fail to reject the null hypothesis. Okay, since the test statistic is in between 0.30896, so fail to reject. Fail to reject hash not means that the variance are equal. Okay, so there is no so we can conclude that there is no difference in the variability of the two process.